So what I'm going to do now is I'll start jumping into various different components of system, and we'll get into more details of it to understand in much depth of each of these components so that we know that what, how, and where exactly we use. We already know about load balancer, but still I would like to mention more in detail. I would like to repeat myself so that you will understand better. So first component is load balancer. Similarly, we'll jump into more topics later on, but I'm just trying to see that you all are aware of this component in detail. Okay. So we have seen where exactly we use load balancer. So it is mainly sits between client and web server or web tier. And we have seen it's a critical leg, as I've given some description here. I will not go and read, but the same points I'm going to explain you. That it is again, it is a critical component. Why? Because it helps you to that whatever traffic that is coming from internet, whether it is 10 users, 100 users, or thousands users, or millions of users, that traffic will be diverted by load balancer. First, it will go to load balancer, and then it will be diverted to multiple backend servers. So that is what the main purpose of it. Why we do this diversion? So that if any server goes down, the other will take care of it. Like load balancer will send that request to whichever healthy server is there. Okay. So that is the main purpose of load balancer is whatever incoming request, if we have to, means load balancer has to pass those requests to the backend server, it will go and verify the server's availability, the server's health, whether it can respond to the request or not. And then accordingly, it will send that request to multiple servers. Like it will go and sending the request to multiple servers. How it sends and how it has been decided that which request goes to which one. So that is all we will discuss later on, but that will be part of this particular sessions. But we will have to first see from details what exactly load balancer does. So here point number 3 is mentioning the same thing, that it keeps track of status of all resources, like or status of all the web server, whether the web server is working fine, whether it is failed, whether it is still responding. And according to the availability of server, it sends a request. So this is even mentioned here. How does load balancer choose the backend server? So it ensures that wherever he is, means whichever server it is sending request, that request is appropriately treated by the web server. Before that, it has to check whether the particular server is healthy or not. So there is a health check that usually health check related to web server, but that will be done by load balancer. Load balancer will first check whether that web server is available or not. So here on the right hand side top, I have mentioned that it will forward the traffic to the healthy backend servers, and it will keep on monitoring the backend server by checking with it, like whether server is listening and responding to it. So if server is failed, if it is not responding to the health check done by load balancer, then load balancer will stop sending or forwarding requests to that particular server. And then it will start moving to a next server. Like it will start sending requests to other available servers. But after some time, maybe once the web server is again restored, then again it will keep on checking with all the servers in the resource pool. Whatever servers are there in the web tier, it will keep on checking with all the servers. If it is failed, it will stop sending the request. And if it is again available after failure, then again it will start sending the request to that website. That is what the whole purpose of load balancer, and that is how load balancer keep the integrity of the system. It will keep on making the system available, keep on giving the proper response. Like load balancer is someone who's sending the request to the backend and as well as giving response back to the user. So it will be serving the user appropriately. So that is what the main idea behind the load balancer. So, and we also have seen this all diagram that how the request goes to load balancer, then to web tier, and then back to data tier. This we have already seen. So I'm just repeating the same thing again, that what is the purpose of it, how load balancer serves multiple user, how it check the backend servers, and what exactly that check means. Okay. So let me move on to the next topic. So here, what we are talking about, like if you look at this chart, it's little different. What we have seen that we put the load balancer between the client and the web tier, but the balance can be done at any stage of the system, at any layer of the system. because your system should support multiple servers. Maybe there are web servers, those are application servers, those are databases. So there are not one, two, maybe hundreds of web servers, hundreds of application servers are running behind it, and multiple databases is also there. So how to even balance them? How to see that which one healthy database is available, which one is healthy application server is available. So that also we need to take. So it's not just that you have to put it the load balancer only between the client and the web tier, but you can also put the load balancer in your backend components as well, or backend layers as well. So here what you can see that there is a load balancer between client and web tier, just like what you have seen earlier. There is a load balancer between web tier and app tier, that is application server. Application server is to do some particular task of the system. Particular task means maybe there are some calculation has to do, maybe there are some analysis has to be done. So that will be taken care of by application servers. So these are servers which will take care of one particular services. Even the microservice architects, these are the servers who take care of one service or individual services. So there will be one service or multiple services are running on the one application server, or maybe one individual service is working on the application server itself. So here also from web tier, it will first go to load balancer, and then load balancer will look at, okay, which application server is working fine, and then it will send the request to that particular application server. And then from application server, if it has to fetch data from database or write data to database, then again we can put another load balancer, which will go and look at the backend databases, which is healthy, which is working fine, which is responding to the request. And then this load balancer also will send the request to the healthy databases. So I hope this is clear. This is not that difficult to understand, but as per my understanding, that load balance is not just to carry the load from external users, like those who are on internet, who's interacting with your system or with your web tier. It is not just here where load balance is applicable, but as well as the load balance is applicable in your internal layers also. Okay, so I hope this is clear. See here I mentioned on top that between the user and web server, between the web server and internal platform layer, that is the application servers or cache servers as well, and as well as between internal layer and databases. That is, again, these are, see, wherever there is a load that is coming in and which you need to distribute to multiple components within your system, then you can think about a load balancer. That you can put a load balance here so that even the backend components, suppose application layer, application server is going down, how you will handle that situation in a sense that how you can send a request to the next application server. Maybe there are hundreds of servers, so you should keep on checking that how many servers are responding. And then you get, so internally also we are taking care of the different components. Even one component goes down, the other component can take care of the requests that are coming in. So load balancer is just to give a check that, okay, what is working, what is not working, which server is failed or which is still working fine. And then accordingly, it will take care of all the incoming requests and sending it to the available servers or available databases. So that is what we have to keep in mind, that that is the main purpose of load balancer. It has to balance the load and it has to serve the request coming in from whether it is from user or whether it's from any other component of the system. That is the idea of load balancer. Let me move ahead. If you have any questions, you can ask. I'll move ahead otherwise. Okay, so now this is one of the important topic of load balancer, that how exactly the load has been balanced, in a sense that how exactly load balancer decide that to which server I should send request. So there are multiple algorithms. So we are going to discuss those one at a time, but we will see that, okay, what are the strategies that have been used, how load balancer decide that which server I should send request or how I should send request. So we are going to look at these different algorithms. So first algorithm is called round robin. We discussed this earlier, but it in short depth. So now it is in more details, we'll look at it. This algorithm is what it does is it sends requests, whatever incoming requests from users, whether user 1, 2, 3. First, it will go to load balancer, and what load balancer will do is it will start sending requests sequentially or cyclic order. What does that mean? So load balancer, if it has backend 3 servers, we are just taking examples here. So servers, maybe n number of servers will be there, but here we are just talking about 3 servers in your resource pool. So load balancer will first send that request, whichever request coming in. It will first request will go to server 1, then second will go to server 2, Third request will go to server 3. And once all the servers are already sent a request, now in my resource pool, server 3 is the last server. Then what I'll do, it's what load balancer will do, it will send the next request again back to server 1. Again after that, server 2. Again after that, server 3. So it will keep on rotating from 1 to 3. And again, 3 is my last server. Again, it will go back to 1, 2, and 3. So this is called sequential or cyclic one. It will keep on sending the request one after another. So that is the round robin. It's like you take like circle. On a circle, these all servers are located. Maybe 10 servers are located. So it will go on in a circular form. Like it will go from 1, 2, 3 to 10. And then from 10, okay, again back, one will come. And then again it will start sending the. So it's that's why it is called round robin. So it is in circular motion or cyclic motion. It will keep on sending the request from one server to another server. And see it here I mentioned that it will be equally distributing. Sorry, it will be equally distributing the load among all the available servers. The only thing is that these servers are of the same capacity. What does capacity means? They will have same configuration. They have same RAM, same hard disk, or same capabilities, whatever hardware capabilities are. They are same. So in that case, round robin is helpful and it is easy to implement and easy to understand. It's not something that we are looking at a complex thing. It is just an easy thing that you have multiple servers in your resource pool and you are going in line from 1, 2, 3, and again you are going back to 1 to send the request. There are chances failure can occur. In that case, it will skip that server and it will move to other server. There are chances are there, but the main idea behind this, it will serve all the requests will be distributed evenly across multiple servers. So that is the idea behind it. So this is called a round robin. It goes in a roundabout form where just imagine like when we talk about round robin, you have to imagine a circle where all the servers are located on the circumference of it and they are number 1 to 10. So first it will go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then after all the servers are done, like they got their first request, then again the cycle will begin with server number 1. So it will get, they all will be getting the second request in sequence. Now moving on to next algorithm, that is least connection. So here you can see in this diagram, I have shown some connections with each server. That one server 1 has 10 connections, server 2 has 100 connections, and server 3 has 1000 connections. So what does this algorithm do in this case? That whenever users are sending requests to load balancer will first look at how many connections available with each server. And load balancer will come to know, okay, server 3 has 1000 connections, server 2 has 100 connection, server 1 has 10 connection. Then it will decide by itself that which server, means it will, because it is monitoring or keeping track of which server has how many connection, it will send those requests, whatever incoming requests are there, to the server which has least connection. So out of these three, server 1 has only 10 connections. So what load balancer will do, it will send all the other requests to server number 1 because it has least connection. Again, here the capacity of server will be same. Capacity in the sense, again, the size of the server will be same. So that's why it will just look at the, okay, server number 1 has only 10 connections. So let me send the request to server number 1. Here again, that description also talk about the incoming request to the server with the lowest number of active connections. Okay. So active connection is more important because these 10 connections, 100 connections, talking about the connections or the requests that are active, that are served by these web servers. Okay. And these things are important because these are different strategies which are applied by load balancer itself, or these you have to configure when you are creating a load balancer in your any of the cloud provider. Because all cloud provider, whether it is Azure, AWS, they all will give you load balancer, but you have to configure that. And according to that configuration, you have to decide that what strategy you can choose, that how the load balancer should send requests to the backend service. Okay. So this is about least connection. Again, this is not a complex term. This is very easy. And diagrammatically, I'm trying to explain this to you so that it will you will understand it better. Okay. See, only thing is that no here and least connection, it has to track all the connections. Which server has how many connections, are those connections are active or not. So these tracking load balancers too. So it will have bit complexity here. So in case of round robin, we are not taking care of anything. Like we don't have to track. It's just health check that you have to do of web servers. I'm talking about web server or whatever backend servers are there. That every load balancer has to do. But apart from that, load balancer has to take care of tracking the number of connections, the backend connections with the servers. That will be done by load balancer. So that is an additional work that load balancer has to do. So that increase a little complexity on load balancer itself. So that's only additional responsibility in least connection strategy. Okay. I hope there is no question. If not, let me move ahead. So here we are talking about further more algorithms. See, we have seen round robin, we have seen least connection, but now here there's one term added, is weighted round robin. Now, what does weighted round robin is? See, as we discussed earlier in round robin as well as least connection, all servers are with the same capabilities or same capacities. What does that capacity means? They have same RAM, same hard disk, same hardware, which is when we create any machine on cloud, then we usually they ask like what kind of machine that you're looking for, what kind of hard disk or what kind of RAM or cache that you're looking for. So in earlier cases, all the servers of the same capacity, that is what we understood. But in the weighted round robin, these machines or the servers are not of same capacity. They are of different capacity. So here, if you look at the left-hand diagram, where server 1 has weight of 0.6 and server 2 and server 3 has weight of 0.2. This is just a number just to show you that server 2 and 3 has capacity lesser than server 1. So just imagine server 2's capacity and server 1's capacity. Actually, server 1 is 3 times than the server 2 and 3. So that means server 1 has bigger RAM, bigger hard disk, bigger cache, or bigger hardware available with it. Or maybe there is GPU and all stored with it. So server 1 is more capable than server 2 and 3. Okay. So here in whenever we do round robin, because server 1 is triple the time of server 2 and 3, what load balancer will do? It knows that it is it is highly weighted server. So it will send 3 requests to server 1 because it can serve that many requests at a time. And then load balancer will send request to server 2 and server 3. Again, this is round robin. So first 3 requests will go to server 1. Then after that, fourth request will go to server 2 and fifth request will go to server 3. And again, it will go back. Then maybe 6, 7, 8 request will go to server 1. Ninth will go to server 2 and 10th will go to server 3. So it is again in circular form, in cyclic form, but because server 1 is more capable than other servers, then this particular server will get more requests because it's can able to serve that many requests because its capacity is higher than other servers. So in round robin also, if there are servers which are with a different capacity and there are multiple capacity servers are there. So according to their capacity, the weightage will be given to it. And according to that weightage, load balancer will send the request to it. Okay, here I've just mentioned an example of content delivery network, that is CDN that we have seen. So CDN usually make use of this kind of strategy. I'm not getting into details of it, but because servers have different capacity, balancing load, it is more effective here. Because servers are different capacity, more servers, like the higher capacity servers will serve more. So again, I'm mentioning here, same round robin strategy, but because the server capacity is different, so they will be weighted differently. And according to their size or their capacity, they will get more and more requests. But again, the request will go in circular form. It's again round robin. It will go multiple times to web server 1 and then to server 2 and then to server 3. Okay. Moving on to weighted least connection. Here again, we have server 1,000 connections, but weight is 0.6. Server 2 50 connections, weight 0.2, and server 3 10 connections, weight is 0.2 again. So here, see, in round robin we have seen because it is highly weighted, it has a bigger capacity, more and more requests are going to it, right? So in this weighted least connection, what is happening is it will all look for weight as well as the least connection. It's possible that weighted server, because it has high capacity, will get more and more requests. So you can see the server 1, because the weightage is high, it's 0.6, it is already filled with thousands of connections. So see, capacity is there because it is a higher server, so we are sending more and more requests, but there are chances that it will get overloaded with the request. So to serve better in this case, in least connection, what it does, this load balancer will do, it will also check, not just wait, but it will also check how many connections are available with that server. And if we find that the connections are more than the other servers, then it will start sending requests to the least connection server. So here you can see in the diagram, server 3 has a least connection. So it will start sending requests to server 3. Because see, weightage wise, the triple the request supposed to go to server 1, but already server 1 has 1,000 connection and server 3 has very less connection. So what load balancer will do, it will check the connection. It will also have the record of what is the capacity or what is the weightage of that server. Accordingly, it will start sending requests to the server with the least connection. And this is again, this kind of algorithm become complex and complex, and that will be taken care by load balancer. Only you have to configure the load balancer accordingly. So the load balancer will again here in send the request, like you can see 1, 2, 3 requests are going to server 3 and fourth request is going to server 2. Reason is they have least connection. Okay, and mostly sometime in e-commerce website, this kind of strategy is being used. Okay, so see, these are complex topics, but they are not difficult to understand. Only these are different strategies, depend on the situation, depend on the system requirement. You have to decide that which algorithm you can use. See, and you can also use these algorithms combinedly as well. Like as we are moving ahead, we are looking at the things are getting combined. We have seen round robin, we have seen least connection. Now we are looking at weighted round robin, and here weighted round robin. It's not round robin, but it's a weighted connections, weighted servers, but as well as least connection. So these again getting combined with their advantage and disadvantages. So these are like you have to choose some advantage from some strategy, and you can combine different strategy together. That will be kind of custom strategy also you can apply. But definitely there are more things come still to come. So I would like to stop here. So let me stop recording.